Today we are going to see what is shear force and bending moment of beams. In the earlier videos we have discussed some types of beams and some types of loads and how to find the reactions for various beams. Today we are going to see how to find the shear force and bending moment of beams. Let me know that what is shear force? What is shear force? Here the shear force is nothing but the calculation of forces on the beam from the right support or left support. Let us consider an example. Here it is a beam. Here having a 10 kN load. Here already we know that RA and RB reactions about the respective supports, A support and B support. Here the load is acting here, 10 kN load. What is the shear force for this? Calculation of or algebraic sum of all forces on the beam from the left support or right support. Here the shear force for this is, let us know that this is RA is a one force and RB is one force and this 10 kN is another force. Algebraic sum of all forces on the beam from the left and right support, left or right support of the beam. Here it is in the upward direction. I am considering the upward direction is positive and downward direction is negative. Then RA is positive, then 10 kN downward, 10 kN minus RB. Here this is the shear force for the at end. We are considering the shear force at support A and at the load which is acted and at B support. There are three steps which is going to involve to find the shear force and bending moment diagrams. Definition: the shear force at any section of beam, because at any section, because we're going to consider the shear force at here only. We're going to take the shear force only at A support, just to A support and just left to A support. Here also just right to the load, just left to the load, and here also same. For this we can consider from right side or left side. That should be equal. That it is equal, but it have to be considered as equal. The shear force at any section of the beam is equal to algebraic sum of all forces on a beam, because we have to take the each and every load, each and every force on the beam, all forces on the beam. We can consider from right to left or left to right. Let us simplify that from left or from right on the beam, from the left or right support. Here this is the definition for the shear force, and the shear force is denoted by SF S dot F or F, simply F. In problems we are going to see what is the shear force for the RA and RB, and at the load, and at the just left to just right to, we can find that denoted by SF or F, and these units are in kilonewtons for SI standards. Kilonewtons for SI standards. If we take the another standards, it will be another standard, another kilonewtons or kgs, let me be. And one more, here we are going to have a sign convention, that is we all already discussed it here, and in the reactions we already discussed it. It is very important, sign convention for shear force. Here there are two shortcuts to remember the sign convention of the shear force. Here, if the, let us consider here, it is support and this is a beam, and we are taking a section here, we are taking a section about here. If it is left side and it is right side, this is right side and this is left side. Left side is upward direction, the left side is upward direction. It is positive shear force. And similarly, the left is downward direction. Left is downward direction. It is negative shear force. Just consider only from the left side. You can automatically remember the another side. If it is upward direction, it is going to be downward direction. If it is downward direction, it is going to be upward direction. Just simple. This can be known as left side, left up, positive shear force. Left up direction, positive shear force. Let us consider left up, positive shear force. If the left support, left reaction or left any force is upward direction, then left up positive, that positive shear force, that indicates that shear force is positive. This can be remembered as LUP, and this can be remembered as here. This is a right support and this is left support. This is in the direction of upward direction, right side upward, negative shear force. This can be remembered as right up negative, RUN, run. These are the two sign conventions for drawing the shear force diagram. What is shear force diagram? These two conventions are used to calculate the shear force of the beam, given beam, and we have to plot the values of the shear force on a graph. That is known as shear force diagram. This is known as, it is represented in the graphical manner. Let us consider this load. This is a support and B support, and the load is placed here. The left side is upward direction, so that it will go against upward direction and moves in the direction of right side, and it is 10 kilonewtons. If it moves down for 10 kilonewtons and it goes like this. This is the graphical representation of shear force diagram. Let us see detailed in problems. Just I have drawn a small diagram here. This is 10 kilonewton distributed equally when it is centrally acted, so that here it is 5 kilonewtons and it is 5 kilonewtons. If you find that reactions for RA and RB, you will get the same reactions here, so that it is 5 and it is going in direction of right side since there is no load for here, and suddenly a 10 kN load is followed on the shear force, and it suddenly falls to -5 and it continues to right side because there is no load here also. It continues and it gains with 5 kilonewtons positive, negative, positive, it becomes 0. Yes, simple. This is a definition for this. Definition for SFD, shear force diagram. It is a graphical representation which one we going to represent on a graphical of shear force values. Shear force values as ordinate on baseline to represent the diagram or to represent the axis of the beam. Is known as shear force diagram. Yes, simple. We're going to do another problem in the next video. A bending moment. What is bending moment? We know that moment, how to find the moment, and taking moments about finding the reactions. We took that taking the moment about A and finding the RB reaction, and taking the moment about B and finding the RA reaction. Here we are adding one more reaction, that one more topic, bending moment. What is bending moment? Here simply that in the shear force diagram, in the shear force we took that algebraic sum of all forces on the section or at the section. Here simply algebraic sum of, here we are taking about moment, so that algebraic sum of moments of all loads about the section. We have to take the loads moment here. It is 10 kN load. Let us assume that the moment for this RB reaction is equal to, for RB reaction the moment, if we take the moment about B is equal to 0, then we are going to consider that we are going to take the moment about B, so that 10 kN into the distance. This is according to the algebraic sum of moments of all the loads on the beam or at the section. If you consider from section only for up to here, we have to take the only loads after this the section. They should not consider the another loads which is not on the section. Here it can be taken from right support or left support. Here is the load. You can take the section head from the right support or from the left support. It gives the same moment for both the reactions or both the supports. You can take any from any side, but you will get the correct answers for both the reactions. For the bending moment also we are having that sign conventions. When here, let us draw one example, that here is a load. Let us assume that this is a bending moment diagram for the load which is placed at the midspan of the beam. so that whether it is a positive shear force, positive bending moment, or negative bending moment. To find out the positive bending moment and negative bending moment, we are going to have two sign conventions, that is sagging and hogging. Let us discuss what is sagging and what is hogging. As we know that we already studied in our 10th classes, or it is a basic knowledge to know that what is convexity and what is concavity. Here it is, a glass of that microscopic glass, we know that. Here let us consider this is concave side and this is convex. If it is enlarging it, it becomes convex. It going to be closer, that going to be concave. Just simple that. Here also same, there is concave and it is enlarging here, so that it is convex. We know that here it is same applicable for sagging and bending moment. If the bending moment diagram or bending moment at the section is considered as positive, here we have already discussed that whether it is positive or negative. If it is positive, if you think it is positive, the bending moment or the diagram or bending moment should be in sagging moment, that here like this. It should be concave and it should be convex. It's simple. It should be concave and it should be convex. The simple definition for this, if you think that is positive bending moment, the convexity should be outside or downwards and concavity towards the inside or upside. Then the bending moment is called as sagging bending moment or positive bending moment. And another one, hogging bending moment. What is hogging bending moment? Here it is reverse for this. If it is convexity is in the upward direction and the concavity is in the inward direction, then it is going to be hogging bending moment and it is considered as negative bending moment. Here positive bending moment and here it is negative bending moment. Just simple notations for this. To remember this, remember that we are going to smiley face like this, S was sagging for smile. This is hogging. Just remember the smile for sagging and remaining one more thing, that is hogging. And we are going to see one more, that bending moment diagram. As we completed that, what is the negative and what is the positive and the values for bending moment, and we have to plot all the values in a graphical representation called bending moment diagram. It is a graphical representation of bending moment values or bending moment plotted values as a ordinate, and the same in the shear force diagram as in the ordinate of the axis of the beam, and plotting the bending moment diagrams. Values ordinate, the axis of the beam is known as bending moment diagram. And tomorrow we are going to see that how to draw shear force and bending moment for a certain conditions, and we're going to draw some. We're going to find out how to take out the values of reactions in a simple manner, which is not lengthy. Thank you. If you are new to my channel, please do subscribe the channel and click the bell icon for my regular updates, and thank you.